An airplane's power plant includes the engine, propeller, and engine accessories. Not only does it provide thrust, allowing the airplane to accelerate and climb without assistance, but it also powers the various aircraft systems by providing electrical power and driving fuel, air, and often hydraulic pumps. At the heart of the power plant is the reciprocating engine, which produces power by burning gasoline inside its cylinders. This causes the back and forth or reciprocating movement of a piston inside each cylinder. Each piston is connected to a rod which translates this back and forth motion into the spinning of the engine's crankshaft. The engine operates on a 4-stroke cycle. The first is intake. An intake valve opens, allowing a highly flammable mixture of vaporized fuel and air to rush into the cylinder. When the cylinder is filled, the intake valve closes. Next is compression. As the piston is driven upward by the motion of the rest of the engine, it tightly squeezes the flammable mixture into a small space near the top of the cylinder. Third is the ignition or power stroke. A carefully timed firing of the spark plug ignites the fuel-air mixture, resulting in a great deal of heat and pressure inside the cylinder, which powerfully forces the piston downward. The exhaust stroke finishes the cycle by allowing spent exhaust gases to escape through the exhaust valve as the piston rides to the top of the cylinder once again. When the piston reaches the top of the cylinder, the exhaust valve closes and the cycle starts over. The intake and exhaust valves are held closed by springs and opened by a camshaft. As the engine turns, it drives the camshaft, which is shaped with strategically placed lobes along its length. These lobes open the intake and exhaust valves on the different cylinders as the camshaft rotates. Reciprocating engines are described by the number and arrangement of their cylinders. Common cylinder arrangements are radial, inline, V-type, and opposed. Opposed engines are the most common on small airplanes since they produce good power pound for pound without creating a large amount of drag as the airplane flies. In contrast to automobiles, airplane engines are air-cooled by outside air, which is routed by baffles across the cylinders and engine. Each cylinder has fins which allow the air to cool the cylinder more effectively. When an engine is air-cooled, a combination of high engine power and low airflow tends to cause the engine to run hotter. This situation is typically encountered during climb-out. The engine temperature gauge should be scanned to ensure the engine's temperature limitations are not exceeded. Excessively high engine temperature will cause a loss of power, excessive oil consumption, and possible permanent internal damage. Operating an engine at a higher temperature than it was designed for will cause loss of power, excessive oil consumption, and detonation. Detonation occurs when the fuel explodes suddenly inside the cylinder instead of burning evenly as designed. This sudden detonation of the fuel is often described as engine knocking. Engine pre-ignition occurs when the fuel spontaneously ignites inside the engine prior to the proper time for normal ignition. Pre-ignition can be caused by hot spots inside the engine or by an overheating spark plug. It changes the timing of the engine and is also often referred to as engine knocking. To prevent detonation, the pilot should keep the temperature of the engine within the recommended limitations. Lowering the nose will allow the airplane to gain speed, which will eventually lower the engine temperature.